Hi everyone and welcome to this lesson. In this lesson we're going to be looking at creating structures. So the other name for structures, and the one that you'll see more and more often, is a UDT, or in Codesys a DUT. So a UDT is a user-defined type and a DUT is a data unit type, but essentially they are both structures. So hopefully you've already got your Codesys environment set up, because I really advocate doing this stuff for yourself as I go along and do this, rather than just watching. Things will make a lot more sense, and if this video is a little bit out of date or you're using an older version, things might not be exactly where you see them now. So it's a good idea to go through it as we do it to find out these little things for yourself. So this is just a blank project, as a default project comes in Codesys. Here I've got my application. If I right click and go to my DUT, it says create a new data unit type, and I'm just going to call this one DUT example. All this stuff here is not available in most other PLCs. It's to do with object-oriented programming, so OOP. We're not going to be using that in this lesson, so leave everything there as it is. So once you've created this, you'll see your DUT editor sort of appear, and you have your type DUT example, which is what we've just created, and then end type, and in between struct and end struct is where we will put our information. So the struct and end struct are common throughout different PLCs. You'll see the sort of keyword struct and end struct, or at least struct, in many different types of PLC. So if I add on, off, I'll put a temp for temperature. That can be a real. And for example, I'll put an array of flags. So all of that's been accepted, and we now have a structure called DUT example. So can't use this yet because it's just a unit type. It doesn't have any memory associated with it. Nothing can read or write to this yet. So we need to instantiate it and give it a variable by which we can access this information. So there's two ways of doing that. You can either create a global variable list, or you can create a POU, such as a function or a function block or a program, and do it that way. But for now, we will create a global variable, and I'll call it motor1. Sorry, I'll call it motor. And then in motor, that's where we declare the actual access variable. And I'm going to put a variable in here called motor1. It's going to be DUT example. So again, we can see that's been accepted. So if I wanted to add a motor2, now I have two instances of my DUT example. One accessible via motor.motor1 and the other accessible via motor.motor2. Let's go over to our program and just make sure that that's the case. So if I drop a few bits of logic and a few instructions, and I put here motor dot, I get my motor1 and motor2, motor1, and I can now choose any Boolean that exists in motor1. And the same over here, motor.motor1, and simply choose. I mean, obviously that logic won't work, but you get the idea that now I have a container for all of my motors, and they all share the same data type. They don't have to. I could have more than one motor data type, one for direct online pumps, one for soft start pumps, one for chemical dosing pumps or variable speed pumps, but they can all be containerized under motor. And I can access those different data types via that motor container. So just to show you what happens if I change that. So if I was to come into here now and add fault and give that a data type of bool, without having to come in here and change anything, I can go back to my my logic here, and fault is now available. So I haven't had to tell anything anywhere to add this new information. It's just been added, and we'll see that in full effect later on in the course when we come to use structures with function blocks. But for now, I hope that shows how you create a structure and a little bit on how they're used. We'll expand on that as the lessons go on.